Hello, everyone, and welcome to the 34th Annual Great Lakes Day. Great Lakes Day is sponsored by Michigan Sea Grant, Michigan State University Institute of Water Research, Department of Fisheries and Wildlife, and MSU Extension as a part of A&R Week at Michigan State University. My name is Angela Scapini, and I'll be your MC for the day. Next, we have Dr. Rachel Hackett, also with Michigan Natural Features Inventory. Dr. Rachel Hackett has worked at Michigan Natural Features Inventory since 2018. She uses her botanical skills to delineate and classify natural communities, document species habitat, combat invasive wetland plant species, and study plants of conservation or cultural interest. Dr. Hackett earned her Bachelor of Science in Environmental Science at Aquinas College in Grand Rapids, Michigan. After 7 years of working in an informal science education in Michigan, Costa Rica, and the Pacific Northwest, she returned to school to earn her Master of Science and PhD from Central Michigan University in Mount Pleasant, Michigan. She devotes her free time to biking, board games, and roller derby. Please welcome Dr. Hackett.
Hello, everyone. Thank you for that introduction, Angela. I'm here today to share the results of a monitoring study looking at the effects of invasive Phragmites treatment in Saginaw Bay, Michigan, focusing particularly on marsh bird use and the plant species that were repopulating those areas. This was a partnership between my organization and the Michigan Department of Natural Resources and other municipalities that own land in the area. Come on, next slide. Let's see there. Here we go. Kind of the goals of this study was to evaluate the effects of invasive Phragmites on marsh bird activity, and that vegetation growing in the area, and to assess the success of invasive Phragmites management in relation to those birds and plants. I led the vegetation effort while my colleague Michael Monfils led the bird effort. I'll try my best to answer bird questions if there are any, but I might have to refer you to someone else. Okay. So this is a map of our study area in Saginaw Bay. We kind of categorized the areas that we collected data from, and we categorized them as either unmanaged Phragmites, which are the white squares. They were managed Phragmites, which are the gray circles, or our reference, what we consider reference sites, black triangles, which at the start of the study were not invaded with Phragmites, but given their habitat and location, we thought that potentially the Phragmites could invade in those areas. So our methods, at each of those points on that map, we conducted marsh bird surveys, and they took place in the springtime during the breeding season. We followed North American marsh bird monitoring protocols by Conway. In short, we went to these points, and in this location, like kind of represented by the circle on the screen, we stood in the center, represented by the little duck. And we had 5 minutes of passive listening for marsh bird species, and then we had 5 minutes of playing their calls and listening for responses. And each point was visited 3 times during that breeding season each year. With our plants, we were focused on the plants that the birds could have been using. So they kind of focused around these marsh bird points. So at each of the points where we did these recordings for the marsh birds, we took 3 vegetative plots, and we identified not just the species in the plots, but the type of plants they were, whether they were floating or emergent. And we also tried to document the vegetative structure, so how high the vegetation was growing, how deep the water was, what the substrate was, etc. And then for each of those marsh bird collection points, we kind of pooled those 3 vegetation plots together to kind of summarize the habitat that the birds were utilizing. Here are some pictures of the results from each of our categories. We conducted these studies in 2018, 19, and 2021. So these were high water level years in the Great Lakes and Saginaw Bay. So we have pictures of the areas where we had unmanaged Phragmites, both in 2018 on the left and 2021 on the right. And we had not much difference in these plots as far as the Phragmites goes, although there was more European frogbit in 2021. Here's some visuals from a managed site. So in 2018, especially with the high water levels, we had a lot of submergent plants being dominant. And we were starting to see some regrowth of Phragmites in some of the plots in 2021, although not all plots experienced regrowth. And here are some of our reference sites. As you can see, the reference sites didn't mean all native species, as we included cattail marshes, regardless of whether it was a native or invasive cattail, as these reference sites. And choosing the sites, there was just no guarantee that Phragmites would ever invade these locations, but we were trying to represent what some of the Phragmites areas would look like prior to invasion. Now, we identified 133 different species across all these plots that we did in Saginaw Bay for vegetation. And one way we examined these plots was looking at non-metric multidimensional scaling, or NMDS. Sounds really complicated, but if I boil it all down, we got a series of graphs which kind of placed a point that represents each of the sites, each of those marshbird points that we collected. And they're kind of clustered around similar species, like other plots that had those similar species. So I'm going to pull up the graph now. So the points closest to one another would have similar species, and the ones farther away would have different species. Now the red circles are the unmanaged Phragmites. And you see, no surprise, it's all clustered around here around, let me get my where is the spotlight? So you have all these red circles representing the Phragmites, which is clustered obviously around the Phragmites. You also had a lot of Utricularia or bladderworts with these species, as well as frogbit and starry stonewort. Now, if we look at managed Phragmites, which were represented by the black squares, they're all mostly on this right side of the graph. They do kind of merge into some of the areas where you have more Phragmites, but a lot of the species that we were documenting in these sites were more submersive species, such as eelgrass or water celery, I think is another common name, pondweeds, water milfoil, both invasive and native species, Canada waterweed, Alodia, can't remember the common name, and coon's tail as well. So we had a lot of submersive species that were coming out in those managed Phragmites areas. And then in our, we had blue triangles that represented the reference sites that we recorded in the 2018 to 2021. So you have some overlap with both of those kind of clustered of areas, but these plots do have a lot more emergent species, such as the cattails, typha, the bulrushes, the Chenoplectus. This is purple loosestrife and sedges. Now, because we had super high water years during those years, we also want to kind of looked at some past data and also mapped some more low water reference. So just to see if there was a difference, or maybe these zones more likely resembled the managed areas in these low water references. But we found as they kind of grouped out amongst themselves, having a lot more emergent species. And these were at those same locations that we did those marshbird studies. That was just for a past study. All right. So, oops, I got to there. There's my mouse. Now, as far as the vegetation goes with the plants, because I'm really fascinated about the submersed plants trend, here's just a figure to kind of show the percent cover of the submersed plants among the other plants for those 3 years of sampling. And you can see distinctly that the managed and the unmanaged Phragmites groups do not correlate. This is the managed Phragmites in the solid line. Down here at the bottom is the unmanaged Phragmites. And here we have those reference sites. So just showing the difference amongst the groups and how, as far as submerged goes, as well as the general plant assemblages, you had the reference sites resemble the managed, Phragmites sites resemble a lot of the reference sites versus the unmanaged Phragmites sites. Now, just for the vegetation portion, just to examine some specific differences among the treatment categories, we ran some models, examined some means and standard error of some of the measurements we took, like the number of Phragmites stems, percent cover of other species, plant evenness, like whether one plant dominated the quadrat or whether there was a whole bunch of different species kind of equally responding to cover. And we did find some interesting patterns here about the structure and the regrowth among the managed, unmanaged, and those reference points. One of the things was that the Phragmites cover and the number was significantly less in the managed points than the unmanaged, more closely resembling those reference points. There had been some regrowth, but after the 4 years, it wasn't to the density of those unmanaged areas. There have been some anecdotal concerns about secondary invasions after Phragmites is treated, particularly with European frogbit. Our data really doesn't support a secondary invasion, like something that happens after you remove the Phragmites. But our monitoring had the same percentage of European frogbit in the treated and the untreated areas. So that supports more of a hypothesis that the frogbit's already there. It's just the removal of the Phragmites allows it to mat up and be seen more readily. So it's more like you take care of the Phragmites and now you can see the frogbit that you have to take care of. And it's regrowth of the submerged plants that I was super interested in. Overall, the species we found were very similar to the reference. But there was this regrowth in those years of eelgrass and the submerged pondweed that wasn't seen in any other plots. It was just very abundant. That might be attributed to those high water level years after treatment of the Phragmites. I also want to point out that the species richness, so the number of different species in each plot, was not very different among the plots, whether that was managed, unmanaged, or the reference. It's still fairly low number on species in that habitat, but they did differ into the abundance of those species and the species richness versus just the number of species. So the managed Phragmites in the reference sites had more evenness among the species, so they were more coexisting versus the unmanaged, which was dominated by Phragmites, but might also have some European frogbit, some bladderwort, some lemna duckweed floating in there too. But it was mostly all Phragmites with very little of the other species. So this kind of lends to a measure of species richness not adequately capturing any change in the system in these aquatic systems. And other measures should be considered for those people that are examining effects after treatment. Now on to the marsh birds. So we went out, had over 700 point counts at 87 random points across the years that were resampled each of those years. They had 15 different primary and secondary target bird species that were detected in each of the categories. And there were small differences in the bird species detected by the treatment category. Sorry. So there was only small differences in the bird species detected by each of those different treatment categories and were accounted for by uncommon species observed sporadically. There were 2 species, sedge wrens and yellow-headed blackbirds, that were recorded at some of the managed Phragmites sites and the reference points, but not at any of the unmanaged Phragmites points. And there was only one species, the Wilson snipe, that was detected only at unmanaged Phragmites points. So this chart I'm showing you now, we used some different mixed models to kind of evaluate the abundances, detections of these birds per point of 8 bird species that we found in our treatment categories. Again, we had a very low number, so it's hard to notice differences. But for all but one species, the Virginia rail, abundance significantly different by those treatment categories. So here on this chart, we have each of the species in this category, and these are kind of the groupings of whether these categories were significantly different from one another. So you had the pie-billed grebe that we found more abundant in the reference areas. Oops, I didn't mean to. So, oh my gosh, I am so sorry. I'm like, I didn't realize that 2 fingers like advance the slides. Oh my gosh. Okay. All right. 1 finger on the mouse pad only. Okay. If you notice here, unmanaged and reference sites had more abundance of the American bittern. So the higher the letter, also the grouping had a higher abundance. Virginia rail, we didn't notice any difference among any of the sites. And then we have some of the other species as well listed here. Okay. And we had a lot of birds that were present in both the managed and the low water reference that had those groups had similar numbers. All right, so management may have caused some short-term habitat loss with some of the conclusions we came up with from looking at these bird groups. For the marsh birds that requiring the dense vegetation, such as the snipe, the rail. Also keep in mind that this was a measure of presence and abundance, not of nesting success or nest presence. We know that they were using the habitat, but not how well or if it was successful compared to other habitats. Also, the abundance of the several bird species in the unmanaged Phragmites was similar to that of the reference plots, but lower in some of the management plots, depending on what species that you looked at. And so overall, this kind of study highlights the complexities of trying to plan, implement, and assess management. We have multiple invasive species presence, complicating a single species management plan. Finding adequate reference sites is increasingly difficult as we have to deal with these emerging species. Finding these wetland services and taxonomic groups that respond differently to management, such as plants versus birds. We had the birds might have a lag time as far as recovering after the invasive species is managed versus some of the plants who seem to recover, but it might also the high water levels of the Great Lakes might have played a part in that plant recoveries. We also had short-term assessments of management does not provide a full picture of the recovery. So we kind of advocate for some longer-term studies to see how something like the birds use might change as the environment itself changes over time. I'd also like to acknowledge some of our funding sources with the U.S. Fish and Wildlife for this project, and further support with the Michigan Department of Natural Resources, other of our staff in MNFI, and several of our field assistants that helped make this possible. And that is what I got for you guys today.
Thank you so much, Dr. Hackett.